today on how it's made. Farmed caviar. Intake manifolds. Motorcycle jackets. And shovels and spades. Caviar is a term for the salted eggs of the sturgeon fish. A pearly delicacy, they've long been the snack food of the privileged, enjoyed for centuries by Roman emperors, Saudi sheiks, Russian tsars, and English kings. A few nibbles still offer a taste of the high life. Caviar is sometimes called black gold. No wonder. A teaspoon of fish eggs costs more than a meal at some family restaurants. For most of us, a little caviar is a big splurge. Overfishing has depleted wild Siberian sturgeon stocks. So at this hatchery in the southern United States, they farm the species for their eggs and flesh. They feed the young fish high-protein pellets. The juvenile sturgeon fish need constant nourishment to develop. A computerized system dispenses feed every 4 minutes. As the fish grow larger, the feeding schedule ratchets down a bit. The fish produce tiny metabolites that are toxic to them. Those are filtered out by bacteria introduced for this purpose. Staff routinely test the tank water to ensure the bacteria are doing their job adequately. After a few months of growth, they transfer the fish to larger tanks. Here, mesh drums filter the solid waste they produce. Pumps constantly circulate the water to move it through plastic nuggets that house the all-important filtering bacteria. Circulating the water also disperses carbon dioxide gas emitted by the fish and introduces oxygen, which they need to survive and thrive. Ordinary molasses injected into the tanks is consumed by the beneficial bacteria, helping them to process the harmful metabolites produced by the fish. After 5 to 7 years of growth, the fish are at least a meter in length, and they should be full of eggs. Workers transfer them to tubs and mix in a gas to put the fish to sleep. Now sedated, the fish can be more easily handled and are taken to the ultrasound station. Using high-frequency sound waves, they probe the sturgeon's ovaries. This gives them a clear picture of her egg production. She should contain tens of thousands of eggs. If not, she'll go back into the tank to mature some more. But if she's ready, they'll harvest the ovaries. They clean the egg-laden ovaries and transfer them by the bagful to a chilled room with filtered air. This is just one of the Siberian sturgeon's 2 ovaries, and it's a mass of roe, fish eggs that are about to become pure caviar. They're extremely fragile and need careful handling to separate them from the membrane. This worker gently rubs the eggs against a mesh screen. She sets the tissue aside for composting and lifts the screen, revealing the thousands of delicate sturgeon eggs. But this caviar isn't quite ready yet. She now rinses the eggs repeatedly with cold water to wash away impurities like bits of broken eggs and tissue residue. Using tweezers, she picks out remaining specks of membrane and crushed egg remnants until what's left is pure and perfect. She pours the eggs into a fine mesh colander. The volume decreases as the water drains off. She weighs the drained caviar and seasons it with salt, measuring an amount that's about 3.5% of the caviar's weight. This precise salting maximizes the caviar's flavor and substantially improves shelf life. She puts the eggs on ice for about 6 minutes to absorb the salt. The salt draws out more moisture, so she drains it one more time. A worker blots up remaining moisture with a highly absorbent paper towel. Another worker pulls away the towel gently, leaving the pearls of caviar intact. She packs it into a lacquer-lined tin and presses down the clusters of eggs to eliminate any air pockets, which would cause oxidation and spoilage. She seals the tin with a thick band of rubber. This caviar has been many years in the making. Farm-produced, no wild fish were destroyed to get these eggs to market. And that means they should appeal to a growing appetite for something a little more sustainable. The intake manifold distributes the air and fuel mixture to the engine's cylinders. Inside, a spark plug ignites the mix, setting off a combustion cycle which propels the vehicle. For optimal performance and efficiency, the manifold must distribute to all cylinders evenly. Whether in an engine with a carburetor like this one, or in a newer technology fuel-injected engine, the Manifolds tubes, called intake runners, feed the fuel and air mixture to the engine cylinder heads. The manifold is made from long blocks of extruded aluminum. First, a computer-guided saw cuts each block to the required length. Metal cutting metal produces a lot of friction-generated heat. A steady stream of water-based coolant and lubricant prevents the saw blade from overheating and breaking down. A computer-guided machine shapes the block from multiple angles, transforming it into the rough form of one of the manifold's two sides, called banks. Later, this bank, which has 4 ports for runners, will be mated with the opposing bank, which has another 4 ports for runners. The machine now shapes the inside of the runner ports, which are curved and tapered in a very specific way. The banks come off the machine with some rough edges. A machinist smooths them out with a handheld grinder, a process called deburring. Once the banks are finished, they go on to a flow testing machine. It measures the airflow in cubic feet per minute in each port. To achieve maximum efficiency, each port must have the same amount of air moving through it at the same speed. The runners have been machined separately. A quality control technician runs a file over the runners and the banks to check for any imperfections. He then cleans all the surfaces with solvent. The aluminum must be free of any oils or other contaminants prior to welding. It's finally time to mate the 2 banks. Workers mount them on a mock-up engine in order to get the fit exact. Then temporarily bolt them down to hold their position. Now a welder takes over. Using a high-precision welding machine, he first tacks the banks to each other in a few spots to secure the positioning. Then he fully welds them together. Next, he attaches the intake runners to the ports. A light tap to make the tongue and groove connection, followed by welding along their perimeter. A manifold has 1 intake runner for each cylinder of the engine. This one's designed for a fuel-injected V8 engine, therefore it has 8 runners. Once all the runners are welded on, he closes up the manifold with front, back, and top panels. He welds these parts as well. Next, workers mount the fuel rails, which send fuel to the injectors. The injectors go on afterward. This is a high-performance manifold with a built-in nitrous oxide system. These are the stainless steel feed lines for it. Nitrous oxide is a compressed gas that's high in oxygen. It allows more fuel to be injected, which increases combustion pressure, giving the engine up to an additional 500 horsepower. They mount the throttle body through which air enters the engine. The pivoting brass blade in the center is an air metering device. The deeper the driver pushes the gas pedal, the more it opens, letting in more air. The injectors simultaneously shoot in more fuel. The result? More power. This sophisticated testing machine checks for leaks and measures several factors, such as the nitrous oxide flow. While the function is the same, the shape and configuration of intake manifolds vary according to the type of engine, in order to optimize performance and fuel efficiency. First conceived in 1920s America, the motorcycle jacket is designed for the open road. Made of tough leather with an off-center zipper that creates a seal, this jacket is the ultimate windbreaker. It also protects the biker from scrapes and cuts in the event of a high-speed fall. The motorcycle jacket evolved from other wind-resistant garments like World War I aviator jackets and duster coats. Styles come and go, but the classic biker jacket has ruled the road for decades. They make it from heavy steer hide. A worker inspects the skins for flaws and selects the best. He also pairs up skins of similar hues and textures, so all the sections of the jacket will match up. He wipes oils from the hides with a piece of sheepskin, then stacks the hides in bundles of 6 to 10. It's now time to select a pattern. In this case, it's a men's medium. There are about 50 pieces in one motorcycle jacket pattern. Cutting the leather takes an experienced hand and a keen eye. The cutter works around any imperfections and chooses the stronger sections of the hide for the parts of the jacket that will be subject to the greatest wear. It's a skill that takes about 2 years to master. They punch out small components like pocket flaps and trim with a die, producing stacks of parts in one swoop. They call it clicking out the parts. These parts of the jacket don't vary in size, so different sized patterns aren't needed. The next worker lowers a hydraulic blade to cut pocket slits in several jacket front panels. This is called the pocket chop. Working from the reverse side of the panel, workers fold back the edges of the pocket slits and glue them down with strong industrial adhesive. They gently hammer the glued border to improve the adhesion. A few taps to both the back and the front of the pocket slit seals this job. A seamstress sews a zipper onto a pocket. Then she stitches the pocket into the panel slit. This is the right panel, and this side of the jacket gets 3 pockets. Biker jackets usually have lots of pockets because motorcycles don't have much storage capacity. She pieces together the rest of the leather shell. In the meantime, another crew rolls out quilted fabric for the liners. They align it with other pieces of the material that have been cut to length. They place a weight on one end and move to the other to cut the material to precisely the same length as the pieces underneath. Once they've accumulated numerous layers, they're ready for the pattern. This time, it's a big sheet of paper printed with the pattern markers. The pattern designs have been precisely configured on a computer to minimize fabric waste. Using sharp vertical blades, they cut along the pattern lines, slicing through the quilted stack. In a matter of minutes, they produce liner components for a couple dozen motorcycle jackets. In the sewing department, the seamstress pieces together the quilted lining and stitches on the label. She mates it to the now completed leather shell, sewing from the inside so the stitches won't be visible. With the job done and the off-center front zipper installed, the next worker turns the motorcycle jacket right side out. She pulls the seams of the jacket over a pointed metal rod. This gets rid of any puckers and rounds out the seams. Using a hydraulic device, another worker installs button-down snaps on the collar. This will keep it from flapping around and distracting the biker. A worker drives the prongs of a metal star into a piece of shoulder trim and bends them back. This and other metallic touches add a bit of flash to the jacket. Made famous on the big screen by Hollywood tough guys like Marlon Brando and James Dean decades ago, the motorcycle jacket is still riding a wave of popularity. Shovels and spades are indispensable tools when it comes to digging into the ground or transferring materials such as soil, sand, or gravel. Lower quality shovel and spade heads are stamped out of steel, whereas the best quality ones are constructed from one piece of forged steel. The head of a shovel or spade consists of a blade and a socket. The socket fits over the shaft, the part you hold. These heads are forged from a single piece of steel, far stronger than those made of a welded together socket and blade. It all begins in the factory's foundry, where workers heat planks of steel about 2 centimeters thick to 1100 degrees Celsius. A massive press then cuts the planks into T-shaped pieces. Each piece will become a head. The vertical part of the T will form the socket, the horizontal part, the blade. The next press, with a couple of strikes, forms a neck, the starting point for the socket. They spread out the neck between giant rollers, flattening and thinning the steel in the process. Then they lay the neck in a stamping press, which chops off the excess metal. Next, they finalize the socket shape. The first strike simultaneously curves it into a U shape and punches a rivet hole. The next turns the ends around to form a rudimentary circle. Then, repeated strikes round out the circle, perfecting it. Work begins on the other end of the T-piece. Rollers spread and flatten it, forming the rough shape of the blade. A press stamps the precise contour. Another then forms the required angles, finalizing the blade shape. The repeated heating, reheating, and forming renders the steel brittle and weak. That's why the next step, heat treatment, is critical. First, they heat the head to 1100 degrees Celsius at a very specific rate over a period of about 90 seconds. Then they submerge it in cool water for about 30 seconds. This heating and quenching, as it's called, rearranges the molecular composition, strengthening the steel. Next step, a coat of paint. Either clear, allowing the natural color to show through, or traditional green or gray. They bake the paint for about 5 minutes to make it ultra durable. The shovel's shaft is made of ash, a particularly strong type of wood. They take a cylindrical piece and saw a 20 centimeter slot down one end, then widen the slot a bit. They sit that slotted end in boiling water for 3 minutes to soften up the wood just enough to make it pliable. Then they line it up with a horseshoe-shaped clamp. A hydraulic ram then pushes the shaft forward, spreading each side of the slot around the clamp. They move the shaft in this clamped state to a slightly heated chamber for a couple of days to dry out, after which the wood assumes this shape permanently. After putting a rivet through the bottom of the split to prevent further splitting down the length of the shaft, they sand the wood to smooth it out. Taper the end that will go into the socket. Mount a riveted handle grip. Then do a final overall sanding. The shaft now goes to the assembly shop, where they put it in a press and mate it with the head. Then they secure it with a rivet through the rivet hole in the socket. The next operation is called linishing. Using a coarse sanding belt, they wear down the wood where it meets the metal, making a smooth transition between the two materials. At the same time, they smooth down the edge of the rivet. Next, they dip the shaft in wood stain. This brings out the beautiful grain. Once the stain dries, they apply a protective coat of varnish. Other models have a metal handle on a wooden shaft, or a nylon handle on a fiberglass shaft. Different designs with the same purpose: to get the job done.